Hello once again, it's Mr. Pete, your YouTube shop teacher, and I'm sitting here in my shop right in front of my Bridgeport vertical mill, and the subject of this video is yet another method, another project that you can make that will allow you to tram the head on any vertical milling machine for that matter. And there are several advantages to this, which I'll show you here presently, but this was not my idea. This was an idea that I got from one Mr. ELLIE PRICE, who is an experienced machinist out in the great state of North Carolina. In fact, he donated the various materials as well as the idea for this tramming device. So I think you'll find this to be very innovative and easy to use and easy to make and fairly reasonable for you to make. So let me show you what the advantages are of this, and then, well, I think I'll start out by reviewing what tramming the head is, just in case you do not know what that means. Most all milling machines, such as this Bridgeport, allow you to tilt the head to the right or to the left for whatever purpose that may be, milling at an angle, etc. But when you're done with that operation, you usually want to reset the head so it's perfectly perpendicular to the table or square with the table. Now that can be done by using the protractor that is built into the head here, but that is only semi-accurate, as you may well know. So tramming allows you to get it virtually perfectly perpendicular. So that's what tramming is all about. Now I've actually made two of these, so this is the earlier version, and I'm going to make another one that is just slightly larger. But again, the advantage of this tramming device, this attachment, is that you do not have to remove the vise, and probably do not need to remove your work from the vise in order to tram it. So take a look at what I'm going to do here real quickly. The tip of the indicator is on the table, and I will swing it around like this. Notice how it clears the vise. Be very careful you do not break the tip off of your indicator, but in most cases at this point you would have to use a mirror to see it, or walk around and look at it from the back side, which is very, very difficult to do. So with this one, you can rotate the indicator to the front so that it faces you. And notice that I'm almost right on tram, that is within a thousandth or two. I'm going to tilt it just slightly so that I can give the demonstration again after I make another attachment. So let's get over to the bench and get started with that. Thank you very much, ELLIE PRICE, for donating the materials for this project. Now this is 1-inch square aluminum, 12 inches long, probably a little longer than necessary, and a little heavier than necessary. The first one that I made actually is 1 inch by 3/4 inch, and a little bit shorter, but ELLIE suggested that I ought to have 8 inches here at least, rather than the 6 inches that I made it. And you can really make that any distance that you want. I think if you make it too great, you might run into problems, so stick with the approximate dimensions that I have given to you. Well, ELLIE also sent me this indicator. Now this is not a real high-end one. It's probably made in China, I'm not sure. It has a 1-inch range. That is more than you need. A 1/2 inch would be plenty, or even less, but it does not have to be a Starrett or a Mitutoyo. This is plenty good for tramming. He also sent these two collars here. These are die-cast 1/2 inch collars with set screws, and he sent a whole bunch of these nylon washers here, and two pairs of these thrust washers. And these work great. It eliminates all friction, but probably a little bit overkill and kind of expensive, so you can get by with the nylon washer, and I'm going to show you both ways that there isn't really much difference between the two. Ellie also sent a bunch of photographs. I will show these at the end of the video, but this is his shop, and notice that he used a piece of that 1-inch square structural steel that you can get at any home center, and even that is plenty rigid. So just go the cheapest route or whatever it is that you have available in your shop. Now there has to be a way of holding the indicator onto the aluminum rod. So this was made by Ellie. I'm not going to make another one because it's just perfect the way it is, but there's a 440 set screw right here, and this is just a piece of 1/2-inch round steel with a hole bored in it. Actually, it's 2 holes. And there's the set screw, as you can see, and this is 3 inches long. Now notice that what he did here, since this is a very, very short boss right here, and it's very hard to get a purchase on that with this little set screw, so he actually made this part with a slight radius. Now, I don't believe that it shows up, but this is about a 2 1/16 inch radius here, which matches the radius of the indicator body. I don't believe that's showing up, but when I install that like that, you will see the fit. Now I'll rotate it a little bit and you'll see that it lifts off. So that's the position that it needs to be located in. And again, this is hollow so that the stem here has some place to go. All right, one more thing here. This is the original tip that came with the indicator. Now he just put it here to store it, to get out of the way so it is not lost, and he made another end here. Well, I'm not really sure if he made this or if this is a commercially available one, but notice that it has a bit of a crown on it, and you know that Starrett and other makers make these tips in all different shapes, sizes, and point configurations. I kind of prefer this one. Here's another one. I'm not going to put that on there. I'm just showing you that that works pretty well when it sweeps across the table. If you use one of these that's too pointed, you're liable to break it off, so be careful with that. So perhaps you have a selection of those tips like I do here. I don't know, in the secrets box. Okay, I've done a little layout, but it actually could be done directly on the milling machine if you had a notion, but there is a center line here. Doesn't show up very well. I did not use layout die, but the first hole here is 1.5 inches in from the end. You could make it 1 inch. And then I moved up 9.5 inches to that point there, so it's 8 inches between those 2 holes. Now we're going to go over to the milling machine and very quickly drill and ream those 2 holes 1/2 inch. And I do not need to show all of that. I believe I'll just show one of them so you get the general idea how that's done. But it is far preferable for you to ream those than to simply drill them. Okay, I've got 2 holes to drill and ream. I'll just show you one. The work is set up in parallels, and I have used an edge finder to get it accurately on center, and that is a center drill, so I'll go ahead and spot it real quickly. And now drill 1/4. And this is a 31/32. And finally I will ream it 1/2, 500 thousandths. Okay, that's perfect. Now I'll turn it around and drill and ream the other end. I do not need to show that. Okay, both holes have been drilled and reamed. Again, that's 8 inches on center. Okay, the next thing you need to do is to put a dowel pin in here, or a dowel rod. Now, it can be soft steel. It does not need to be hardened. 1/2 inch diameter. So here's one, perhaps a little bit too long. This is 3 inches too long, and I will press it in here. Now, if you don't have a good fit, you can hold it in with Loctite, or you can put a set screw, or you can pin it if it's soft steel. It's just not too critical. Be right back after I press this in. Okay, I've got a real good fit here. That's not going to come out. If I ever do need it out, I can drive it out, but it's pretty firm. Now this hole needs to be a real good fit for the indicator. A sliding fit like that. And by the way, if this lug bothers you, you can remove it, saw it off. Okay, this is Ellie's picture, and he allowed about a 1/2 inch right there, and it might vary depending upon the height of your vise. But I put the first collar on like that, and I believe I'll use the thrust washers first. So one of the hardened washers, the bearing itself, make sure they're clean, another washer, and then insert it into the bar, and then same thing on the top. But of course, if you're using the nylon washers, you would just use one of those. Now before you snug this up, be sure and using your fingers like this, pinch it together the best you can. It doesn't have to be super tight, but you do not want any play or any slop, or you might be defeating the purpose of the whole thing. And now you can see that it turns, rotates very freely, very easily, but yet there's absolutely no play or backlash. And it is now ready to use. That's all there is to it. Now if this bothers you, cut it off right here. If that's too long, and I might do that later on at some other time. If this is too long, cut it off. Also, if you wanted to, you could drill more holes along here so that you can change the length of this, as Ellie did by using that structural tubing. Okay, the attachment is mounted in a 3-jaw chuck. It could be a collet. It's important to note now that this can only be used when you are tramming the head from left to right. It cannot be used to tram it after you have knotted the head. But notice now it will clear, and you have to be careful that it will clear the column back here. And we'll come around to the other end, and you ought to be about on the center of your vise. Notice how much that it clears the vise by. And you can raise and lower it either with the table or with the quill. Now if you attempt to rotate the spindle in this direction, you will strike the vise. So you've got to come around from the back side. Also, do not, whatever you do, turn the machine on. As a matter of fact, I recommend that you unplug or pull the fuse or breaker or disconnect the power from the machine while you do this. Should you turn it on inadvertently, it could kill you and certainly maim you. So be careful of that. I brought the camera around at this angle so you can see that there's not a whole lot of clearance right here. But if you need more clearance, you can bring the ram out a little bit. I do not recommend that even though we have a full inch of travel here, that you use even half of that. Better just a little bit, and I like to bring it down close to the table, lock the quill, and then raise the table. You can't see it, but I have my hand on the knee crank, and I'm going to bring it up to 12 o'clock. That way, as I rotate this, I will not break the tip off. However, you may find it necessary to raise that a little bit as you rotate it past the T-slots. One other caution here, since there's always a little bit of flexibility, even in a 1-inch beam, or some of it might be in the dowel pin here, even a small amount of pressure will deflect the needle, as you can see. So do not turn it by holding this beam here. Use your hand on the chuck. Okay, let's take a test reading. I do know that I am in tram right now, but looking at the indicator, you'll see that it's on 0, and I'm going to rotate it 180 degrees, like that. And now, this is the beauty now, that you can just turn that around, take a look at it, and you can see I'm within 1,000th, maybe even a little closer. Now remember that since this is 8 inches here, I am checking it over a distance of 16 inches, which is considerable. So even if you're off 1 or 2 thousandths here, you are really incredibly close to being truly perpendicular. But if you want to get it perfect, you can do that too, although it may be a little fussy. Okay, let's do it again, but do you notice any difference? Yes, I put the nylon washers in there in place of the thrust washers, and I don't think we'll see any difference at all. Another thing to point out here is that make sure that your table is absolutely clean, no chips, no swarf, no oil to amount to anything. Now if you have a rough table, you will need to dress it with a hone, or it may not be accurate as you hit high spots with the tip of your indicator. Well, let's swing it around now with the nylon, and I don't think we'll see much difference. And again, within 1,000th. Now up to this point, I really didn't show you how to tram. I showed you how to check to see if it was accurately located or accurately trammed. But now I'm going to take my wrench and I'm going to get it just a little bit off of 0 here. So if you have never seen anyone do this, on a Bridgeport we need to loosen 1, 2, 3, 4 of these 3/4 inch nuts. Now I'll put the camera down on the indicator here and zoom in just a little bit, and I'm going to put the wrench on the worm up here, which you can't see right now, but watch the indicator point, and I'll just take it a few thousandths off, perhaps 5. I'm about 8. So let me swing it around here 180 degrees. Take a look at it, and you can see I'm about 8 thousandths on the other side of 0, so I'm a total of what? Probably, I'll look at the, I'm looking up here at the protractor now, and it really appears to still be on a 0 up here, so you can tell that, that's not all that accurate, and that's not a good method of tramming. It only gets you in the ballpark. You can see by the indicator that I'm quite a bit off. Again, looking up at the head, recall that I loosened those 4 nuts, but this is the bolt head that's on the worm that allows me to tilt the head. Now don't loosen these 4 nuts up too much, just slightly loose, or you will really have a problem. So you're not going to see me do it anymore up here. I'm just pointing out what that nut looks like that's on the worm shaft. Okay, watch the pointer on the indicator now. I brought her back on 0, and I'm going to spin it around now. See what we got. And you can see I'm right back on 0. That was easy enough. Okay, now I'm going to tighten these 4 nuts up evenly, kind of like you were tightening up the front tire on your F-150. And there is the likelihood that we'll see some movement here. So you may have to tram several times. So you can't see me tighten these, but I'm going to snug them up in a crisscross pattern. And the needle is not moving. And all 4 are tightened. And the Bridgeport is trammed and is ready to use. Now, it wasn't that easy using this new device by Ellie. Now, you're going to absolutely love this thing if you ever need to tram it and do not want to remove the vise, which is a chore in itself. And furthermore, my wife is going to love this as well, because now I can sneak this back into her dresser drawer, because she's been wondering what happened to that thing for the past 6 months. This video is so long that I was not planning on showing how to tram the machine in the knotting direction, but I think I'm going to cover that real quickly. First of all, just for a little variety here, I changed the tips on the indicator and installed one that is quite convex. Bridgeport mills and many other brands as well have the capability of tilting the head from front to back by a few degrees, and we call that knotting the head. That's a feature I very seldom use, and I'm hesitant to use it, but let's talk about how it's done. In order to nod the head, or to tram the head in the nodding position, we have 3 bolts here, 1, 2, 3, that need to be loosened up a little bit, and we can refer to this protractor when we're knotting, not the other protractor. Again, that's only semi-accurate, but it does nod both 45 degrees this way and this way. I didn't realize that. It's so long since I've done it. But after loosening these 3, we put a wrench up here on this other bolt, which is connected to a worm. Now, when I talk about worms, this is the worm, and there's one down in here. This is just a sample. And there's one here when we tilt the head from left to right. So that's what I'm talking about when I'm talking about the worm, and then there's worm gear in here as well. And in here, so 1, 2, 3, and then it can be tilted with your other wrench. Okay, I'm going to check to see how close it is. Actually, I have already checked and it's right on the nostril, so I'm not going to loosen those bolts up, but you can clearly see here that I'm on 0, and I'm going to move this around 180 degrees like that. Notice that it barely clears here, and now I have to crank the table in to its extremity. It's already moved as far out as it goes. Now I need to move it as far in toward the column as I can. Okay, let's zoom in a little bit here, and you'll see that it's within a 1/2 thousandth, so there is no adjustment that needs to be made. But check this from time to time, because a very heavy rough cut can sometimes cause just a little bit of movement. But again, what we're doing here is you can sweep the entire table until you get 0 on all your readings. But obviously we have to move the table out, which is a little bit time consuming. Just a few additions and corrections I'd like to make as I wrap up this video. And number 1 is, you might have noticed in the close-ups that I said I was right on 0 with the needle here on the indicator, and I actually was 1/1000th or so off. And there are several reasons for that. Number 1, my general incompetence, but number 2 is parallax error, because I'm sometimes looking not straight ahead but off from the side because of the camera angle, and I do not want to get in front of the camera lens, so that's a reason. Also is the fact that my eyesight is getting poorer and poorer, and sometimes I'm standing a couple feet away from the indicator as I look at it, but later in editing I can see, wow, it really shows up in the close-up. And one other thing I want to show you, and I guarantee that at some point you're going to damage or break the tip on your indicator when you swing this past the T-slots. So to rectify that, I have wrapped a very small spring around here that has a extension on it, so I can easily lift it and not damage the point. I'll show you a close-up of that in a minute. Now, we typically did that with other indicators, such as this Mitutoyo, by this little knob here and lifting the indicator point. But we no longer have access to that because of the way this attachment is built, so I thought that this was a pretty good little solution to that. You could use a wire tie or something else a little bit more crude, but I'm using a spring, and that just works dandy, doesn't it? So to make this little attachment, I just took a spring out of the selection that I have that is fairly light and manageable, cut off a length of it, and then I did take the liberty of annealing the end of it so I could straighten it out and have that little lift point right there. You know, I'm always looking for alternate ways of showing you how to do things that might be simpler, so another method would be simply to take one of these wire ties and wrap it around the plunger like that. You can position that any way you want, and then I would typically, for neatness, clip this off like that, and we've got pretty much the same thing right here. Well, that about wraps up this video. Thank you, Ellie Price, for the idea and the materials. And I'm all set with this, and I believe that I will save this other one too if I ever want a shorter distance here between the centers. Now be sure and watch at the end for these photographs from Ellie that I'm going to show you. And thank you very much for watching. I'll see you next time, but now I'm going to go into a rather lengthy extra credit for those that want to see and pick Ellie Price's brain for yet another good idea. Ellie brought up a subject that I had never heard of or thought about, and it is really not a problem for me, but it may be for you, and that is table sag, meaning that the table on a milling machine has a different reading on the indicator on one end than it does on the other because the table is sagging due to wear, and probably most of the wear down below on the knee. Now there's not a whole lot you can do about that other than a total rebuild or compensate for it. This machine had an easy life. First of all, it's only the 32-inch table. They made the tables, I think, in 36 and 42 inches as well, and it might be more apparent on a milling machine with a longer table. Now this machine led a rather easy life. Even though it was made in 1965, it resided most of the time at Joliet East High School, and I don't know how much use it got there, but it was in storage for a while, and then they closed that school, and it, as I said, sat for a while, and then I bought it. So it's really a machine with very little wear, because I probably only put 100 hours a year work on it, and I baby it. So let me show you what we mean by table sag, but it's not going to show up very much on this machine, but it may on yours. I have just cranked the table down to the extreme left end. Matter of fact, it's gone just about as far as you can go by looking right in here. And now I'm going to take a look at the indicator and zero it out. Okay, I'm right on 0. Now I will crank it down to the other end and do the same. Okay, I'm clear down at the other end, and as you can see when I give you a close-up of the indicator, it is within 1,000th. I need to move in close. No, it's 2,000, so there is a table sag or a difference from one end to the other on this machine of 2,000ths, which is really the diameter of a hair, so it's not a whole lot. Just showing you one other application for this tramming device. And now it is the end of the video. So long for now. Watch the still pictures, please. See you next time.